very straightforward program. Okay, but these are two different classes. Now we have to understand what is the stack and heap memory, right? Like what variables are stored where. So let's first lay down some rules. Okay, the rules which Java has. First of all, what is stack, right? Stack, as I said, it's a data structure. Again, we are not going into understanding what a stack is or what a heap is, right? But just try to understand these are two data structures which here is used in the memory to store some data. Okay. Now stack looks like this. Okay. Stack is just to give you one bit of small information around it. Again, we'll cover stack in the case when we start working on DSA. But here, just for the understanding, right? Stack is something like you have seen, right, in parties or somewhere, right? You see a pile of the plates, right, one on another, right? That is like a stack of plates, right? So what you do is, so it's like a structure like this where you are keeping one thing above, I mean, right? So these are all placed one after another on top of it. So how does the stack look like? Whatever you place on the top, right? So it's like, first of all, let's say it's an empty stack. So you will place something here, right, at this position. Then you will place something after this, right? And then after this. So this is like when you're adding some items to that stack. If you have to remove the items, generally what you will do is you will pick it from the top, right? So what does it mean? It says it's a last in where you're providing the value, okay, on the last item. And it is like the first out. Sorry, this is what I mean, right? Last in, first out. Yes, last in, first out. So this is what is termed as LIFO. Okay, so this is the LIFO part. Again, you do not have to understand any of this. I'm just explaining since we're discussing stack. We will discuss all this in our DSA class. But over here, just understand what a stack is. Okay, a data structure of stack looks like this. Now, what is a heap? Again, heap, you can understand it's a form of a binary tree. Again, a part of a DSA. So again, I will not go inside this, but it's a type of binary tree, which will where we will use here to store some values. Now, directly coming to the part, like I told you one thing, like Java will use these two data structures here to store some variables and the value, right? But what kind of values would be stored where? Okay, so there are let us lay down some ground rules. When you talk about stack, right? What kind of variables it will store, or what kind of data it will store here is it will store all your local variables. Okay, all your local variables plus any method which you call, right? I mean, whichever you create, right, will be placed at this stack. What will happen on the heap? All your instance variable will be stored here. Okay, all your objects, right, which you create, all your objects which you create, right, all objects will be created in the heap only, right? And there is one more thing. Just a second. I don't remember. Just a second. I'm missing one part. Yes. Okay. Arrays also. Okay. So arrays also are stored on the heap. Okay. Now, one last thing. So again, just remember this rule first of all, right? When you talk about stack, you would be placing these two kind of things on the stack. When you talk about heap, you would be placing these three kind of things on the heap. Now let's do one thing very quickly. Let's take this code, or let me take a snapshot of it. Just a second. Yeah, here. What is happening here? What is happening? Just a second. Just a second. Huh? Okay. Yes. So this is our program. Let me copy this, and here's the program. Let me just, can I paste it here? Okay, just a second. Let me save this. Memory program. Let's save it, and let's just upload the file. Okay, so we are good. Okay, I hope this is visible to everyone, right? Uh, my battery. Just a second. Okay. Okay, I think we are good now. Okay, so let's now just do some understanding here, right? So let me create two memories. I mean, so see here, this is like our stack. Okay, so this would be our stack memory where I would be placing things here, right? And you can understand like this is the heap. Okay, where I would be placing the thing. Now for stack, I told you what kind of things I would be placing in the stack. It would be local variables, right? And the method, right, which I'll be creating. Second of all, in the heap, what I will be placing, I would be placing instance variables, and I would be placing my all my objects here, which I will whatever I will be creating. And the last part is about arrays, right? Arrays we have not created arrays, but we'll talk about arrays separately. Okay, so let's start. So first of all, tell me, Sudhakar, if I start from this line, public class dog, right, and I go inside this dog class, what is this caller C here? Is it this is this?
Column is an instant variable. So
It's
that
an
is the
instance variable,
type of caller data type.
right? It's
That's
an instance variable, right? It's an instance
instant
variable
variable.
as of now. We have not created an object here, right? Everyone understand this?
Yes.
We have not created an object here till now, right? It's like variable declaration, right? And what is the data type of it? The data type is what? Caller,
Caller.
right? Everyone? Okay. So this is an instance variable. So where do we keep our instance variables? We keep it in the heap. So I will add here C. Okay. I've added C here. Okay. So whatever variable we are creating, we are just would be placing them. So this is C, right? So I placed on the heap. Now let's move ahead. Now we see string name, right? But again, this is what? An instance variable again, right? An instance variable. So where I will be keeping it? Name part. Sally,
Uh, Same at the same place where you kept C.
right? The heap part,
Yeah.
right? So I will
Yes.
keep name here, right? So instance variable, right? Because instance variable needs to be kept here. Now we are moving ahead and we saw this line, public static void main. Main is a method. Where do we keep method? Where do we keep main?
Stack.
Main is a method name, and this is where I've mentioned, right? So it will be placed where? In this stack. Okay. Again, remember
Yes.
the, just
How
remember
are
the
you
rule.
defining it? Where to keep what? How are we getting to know it?
I told you, right? You have to remember this rule that within stack, these two things would be placed like local variables and method. And in the heap, you have to place instance variables, objects, and arrays.
Okay.
Just remember this rule, right? And just read through the program, and then just try to understand where does Java is keeping all of these. Okay, one by one, right? So main is a method name where it will be kept in the stack, right? As per the rules. So let's place main here. Okay. Now tell me what is string args. What is args here?
String array.
Array,
It's a
right?
local.
Yes.
It's an array here. Where do we keep arrays?
In heap memory.
In the heap memory, right? But again, as of now, did I create an array here? How do we create array? The arrays gets created like this, right? Equals to new string and this, right?
Yes.
Right? Maybe this or maybe like what we understood yesterday, right? By assigning some value, right? This is how you create array. Arrays are getting created when you use this new keyword here, right? Like this, right? This is how you create an array. Here, what you have done is you have just declared the variable name which would be pointing to an array, right, everyone? And what? So first of all, args here is a variable name, right? It's a
Yes.
variable name which would be holding my array. Are we getting this,
Yes.
right, everyone? See, how do you create variables, right? You create variables like this: string name equals to, let's say, Akhil, right? Try to understand this. This part on the left hand side is just the declaration part, right? And here on the right hand side, it's an installation part. नहीं, just a second, huh? Sorry. Okay. So what I was saying is, if we create a variable like this, right? A variable of type string and equals to value, right? This part here, right? This is called what? This is like you are declaring a variable, right? This is just a declaration. But again, you're just declaring a variable. And right hand side is something where you would initialize, right? Now, whether you are creating a variable like this, so it goes like this way. If you're creating an array, right? Again, for the same array also, right? This is still a variable name. Right hand side is the array, right? New string, let's say 5, right? So this is what you're creating an array here. So if I see this line again, right? String args, what is this? This is still a local variable, right? When I'm why I'm saying local variable, because this is getting created inside a method, right? Everyone, which kind of variable it is? Local or instance variable? We have only two variables, right?
Yeah. It's a
It's
local
a local variable, right? It's a local variable. Where do I store local variables? Here,
stack.
right? Stack. So let me add args here. Args, right? So I created args here. This is main, this is C, and this is name, right? So until now we have read these four things. Now let's move ahead. Dog D. Now D, dog D is a again a local variable, right? What is it? What is the data type of D? It is dog, right? But D is a local variable. Again, we are okay with this, right? Why D is a local variable? Because you are creating this variable inside a method, right? So let's create D here, right? On the stack, you can see the rule. So let's place D here. Now let's go ahead. Now here, this is interesting. At this line, you are doing what? You are saying D equals to new dog, right? As soon as you see this new thing, right? What is happening here with this line? New dog. It is creating an object, right? It is creating an object, right, everyone? This part is creating an object. And then once the object gets created, it is getting assigned to my D variable, right? Where does the object creation happens? It happens on the heap. Okay, it happens on the heap. As I said, objects are created on the heap. So what will happen is an object of dog, right, would be created. And who would be pointing to this object? D from stack would be pointing to this object here. Is it making sense? What is happening here? There are two parts, right? Dog D, D equals to new dog, right? So when you say dog D, right? D is just, you're just declaring a variable. Okay, you're just declaring a variable. And this, since this is a local variable, where it would be sitting? It would be sitting in the stack. And as soon as you really create an object of that class by using this new keyword, where does that object gets to sit here? It sits in the heap memory, like this. Okay, and who points to this object here? D, right? You can see at this line, D is pointing to this dog object here, right? Okay, Villain, is it any query on this, or we are good on this part?
Yes, okay.
Okay, great. Okay, Kusuma.
Yes, Akhil. I'm good.
Okay, Fizula, I think for you it is good, right?
Yeah, it's fine.
Okay, great. And Siali, you?
Yeah,
You're understanding this, right?
yeah, yeah.
Okay. Okay, let's move ahead, right? Now, when we did this, right? D equals to dog here and D dog. Okay, we will understand this line later, but let's move ahead, right? So we are keeping it as is. Okay, we'll talk about this again. Now see here, right? If we go to this method, public void go. Now see, this is again a method, right? Where does your method go? It goes in this stack. So let's place it somewhere. Go, right? So method go would be placed on the stack like this. Okay. See, I am not following the rule of LIFO right now. I will, right? When I will start executing this program, I will start showing you, right, how it really works. But just for the understanding, I'm just placing them randomly here and there within stack and heap. Okay. For stack, it matters like how the values came in. Okay. So we'll talk about that part also. So here, public void go. So go will go here, right? Now, if we go ahead, we see another local variable, which is dog, right? So where, and this is a local variable, where I would be putting this? I would be putting it in this stack, dog, right? This dog is here, right? So let me write it here again. This is a local variable. This over here is also a local variable. This over here, right? New dog, right? It is an object, new object being created. Here, go and main, right? These are methods. So main, you point this is a method. Similarly, go is a method. Where do you keep methods? In this stack, right? So I keep dog here. Sorry, go here. And here dog here, right? It's again a local variable. It's a local variable. Local variable. Where will I keep it? Here only in the stack. If I move ahead, if I do C equals to new caller, what was C? C was a instance variable. Where I have kept it? I have kept it in the heap, right? As per the rules. So C is placed here on the heap, right? Now what I'm doing is I'm creating a new object of the caller class. I have another class with the name as caller, and I'm creating an object of it. So Sally, you tell me, where would I place this new caller thing? I cannot hear you.
In the stack only where we are storing the methods.
What is a new caller?
It's
It is,
instance.
yes, it's an instance or an object creation, right?
Yeah.
Where do I create objects?
Yeah, in the heap, in the heap.
So I'll be creating a object here, right?
Yeah.
Okay. And okay, so I'll first let me create an object of caller class, right? So this over here is again an object. Let me write here, it's an object. So where do I create it? I created this on the heap, right? Now see here, who is pointing to this caller object? C, right? C is the variable which will be holding the this object here, right? Which you're creating. Where is our C placed? our C is placed on the heap. Why? Because C was a instance variable. So who is pointing to caller here? C. Okay, C. So C is the variable which is pointing to our caller object, right? Let's move ahead. Again, we have dog dot set name. Again, a method invocation. And here, let's go again. I will cover this part again. But let's see here. So here, if we go this right, set name is again a method name. So Ashok, where should I place set name?
Method should go to stack memory.
Right. So set name. Right. So I place tech here. Now, sorry, set name here. Now, if I move ahead, string dog name. It's a local variable.
Yeah.
So where should I keep my dog name?
Stack.
Stack again, right? So let me create dog name here, right? And I am placing this dog name right here, and I'm assigning it to a name variable. What is my name? Name is where?
It's
Name is my,
instance.
it's an instance variable, right? So this dog name here, right, is being accessed from where? From this name, right? Now see this. You getting this? Are we getting this? Right?
But means where is this? Means why we are trying to understand it? I mean, I need to.
I'll tell you. I'll tell you everything, right?
Yeah.
But first, you have to understand like how where these things are going, right? If you understand this part, it will come. I mean, step by step, right? First,
Okay.
let's understand like how things are getting stored in memory. Let's say this is the objective of today's learning, that we want to understand if we have created some objects, some variables, some local instance variables, some methods, right? Where does all these get saved in the memory? Okay, let's say that is the only objective I have for today. Okay, so
And
if
this is
that is,
same for every program which we write.
this is,
Same for every program which we write. It will be behaving in this way only.
yes, this is the rules of Java, right? Whether you create one class or 100 class, right? The rules are same. Okay,
Yeah.
okay. One thing over here, right? So we covered all of this, right? So now, but we missed one thing. Okay, one last, I mean, one thing, when we covered string, when I think we covered string day before yesterday, right? I
Yes.
told you string here, right? If you understand this string, I wrote this line, string name equals to Akhil, right? Now you could write, you could create instance variable of string. I mean, let's see this, right? You could, if I ask you to assign a value to a string variable which is name, the value as Akhil, right? Or if I ask you, so this is one of the way, right? The second way is you could do something like this: string name equals to new string Akhil. Both are same thing, right? We discussed about this, right? And here you can understand now. I think with our yesterday session on constructor, it will be making sense that I'm invoking a constructor of the string class which accepts some inputs, right? Which accepts some input. Now this is how you create it, right? What I wanted to tell you about string is, in this case, right? This Akhil here, right? This would be like an object. Okay. Again, remember it like an exception for strings. String is a very exceptional case in Java, right? Where a lot of things are happening differently. So understand here, whenever you create a variable of string, right, and assign a value like this, right, on this part, it would be doing what? It is any see anyhow we understand this part, right? That this and this are same, right? Whether you do this or you do this, it is doing the same thing. Now, where does your objects gets created? As per the rules which I explained, it gets created on the heap only, right? It gets created on the heap only. As soon as you do new string, right, it creates an object of string right here. But what would be the value of that object here? Akhil. Okay. So for string again, remember whenever you're doing this, whenever you do something like this, either this or this, what is happening is it creates an object here on the heap and of string type. So this is a string object. Okay, it's a string object which got created, and the value which I've assigned is Akhil there, right? So whether you do this or do this, it is both doing the same thing. Ashok, is it clear? Why I'm saying this?
Yes, yes, Akhil.
Because
But
whether
in one thing, this will show as a different reference points. Like when we say like double is equal to, it will show as false. Whereas when we use dot equals, it will show as true. It will compare the text using equals method. Whereas in double equals to, it will compare the references. As
for
soon as you write new, it will create a new reference.
will
References, yeah, yeah.
you're right. You're right. You're right. Right. But again, for one thing you're not correct is for strings, right? What happens is if you do double equal to, okay, I think we'll talk about it when we discuss the equals to class, right? And the other operations. So it will come. So I think it will make sense when we talk about collections. I think there we will cover the topic. Okay. But as of now, just understand if you do this new thing, right? When you do a new keyword in Java, what does it do? It creates an object for you.
Yes. Yeah.
And here we're trying to create an object of string class. So this is an object being created, and the value you currently have in that string is Akhil. Right?
Yes. Right.
Okay. Sudhakar, is it making sense?
Yeah, actually, we have a string constant pool concept, right? Where whatever the literal or object are stored in the string constant pool, right? Even if it is a making, I mean, we are initializing a string with a constant type, I mean, a literal. I mean, the first line we did as literal, right? The second thing also we object. But the thing is, in Java, the strings will maintain a string constant pool where even it, everything is treated as the object, right? If it is the same name, we have declared in the first line and we have declared in the second line. Same Akhil is pointing to the same reference variable, right?
Okay. Yes. Again. Okay. So you're talking about something else here right now. Okay. But okay. See whatever you're saying, right? I will come to that point. Okay. But as of now, just understand that whether you write this line or this line, right? It is doing this part only, right? It creates an object of string type and it assigns a value. Whether when you do a new initialization of another variable with Akhil, what happens? We'll talk about it. Okay. I got your point, what you're trying to say, but let's leave that topic as of now and just focus on this part, right? So that we can understand this topic first, and then once this gets clear, right, then I will move to the topic which you are mentioning, which is again an important part for string. Okay. Okay. Fizula, this is clear to you, right?
Yeah, it's clear.
Okay, great. So we create, so here, right, what happens is for string, right? See why I'm specifically saying about string is, again, if you use this format, right, if you use this format of creating an instance of a string thing, right, then it is obviously clear, right? You use the new keyword, so it's like an object. You will create an object where in the heap, and you're just assigning this value. But when you use this, right, you may feel like it is not creating an object, and that is what I'm trying to focus on. No, that is not the case. What is happening is internally, this is the line which is getting executed. Okay, this is the line which is getting executed, and what is happening here is it is creating an object. Okay. Okay, I think we understand this part. Okay, now why I explained you that. See here, in this line it says dog dot set name ico, right? Dog dot set name ico. This ico is what? It's a string value. Okay, it's a string value, right? It's a string value which you are assigning to a string variable of dog name. So I mean, ideally what is happening is it's something like this is happening. String dog name equals to ico, right? Internally something like this is happening, right? When you're invoking this here, right, it sets this value to this dog name, right? And this is something which will happen internally. And it is about a string thing, right? And if this is happening, you have to understand like something this is happening internally. New string ICO. And as I explained, right, as soon as you do this, right, as soon as you do this, it will create an object of string class, okay, of string class. What will the value it will be holding? Akhil. And in this case, sorry, in this case, it will be holding ICO, right? Okay. And who is pointing to ICO value now? Dog name. Okay. Who is pointing to ICO value? Dog name. You can see. Where is dog name placed? It is placed here, right? Dog name is placed here. So dog name is pointing to whom? It is pointing to this value, right? And name was pointing to dog name, right? Okay. Now let's see what happens, right? So let's just review our all the things. We just segregated things inside stack and heap, right? And this is how it looks like. So again, I'm repeating, for this stack, we store local. What does stack hold? It holds local variables and it holds methods. What does heap stores? It stores instance variables and objects and arrays, right? Okay, so this is what it does. Now let's just do it again. If you see caller C, it's an instance variable. This is an instance variable, so C came here and name came here, right? Because both are string instance variables. After this, if you move ahead, main is a method, go is a method, set name is a method. So all of these three would be going here. So main is here, set name is here, and go is here, right? In this stack. If you move ahead, look, what are the local variables here? Args is a local variable, D is a local variable, dog name is a local variable. So args is here, dog name is here, and D is here, right? Args, dog name, and D, right? So everything is here. One last thing which is pending is this dog. Okay. So here also, right? This dog is also a local variable. So this is also placed here. Okay. So we talked about C name and we got all this. The last part is this objects which are getting created. Where do you store these objects? So this is one object. This is another object. This is the third object, ICO. Where do you create objects? You create objects here, dog, collar, and string value, right? So this should be pretty clear, right? Where you are keeping what thing. Okay. Now the last part, we have to understand how the execution really happens. Okay, sorry. You have to understand how the execution is happening, right? That is the see again. I am answering Sally your question now. Why are we learning this? We have to understand the flow of our execution. How does our flow works, right? So that is the part which will come, which will be discussing now. Okay. So, but to understand that part, we have to first understand how the segregation is happening of different things inside the memory. So, what is getting stored in stack and what is getting stored in heap. So, let's start our execution now. Now, to understand this again, right? I think we will have to again create one more dashboard so that we can understand. It will become very messy now. Upload memory program home, right? Like this, and let me again create a space here for this is the heap, right? This is the heap, and again this is the stack. Okay, this is the stack. This is the stack. Let's start creating especially the stack part. Now see, how does Java works, right? I told you we discussed this. How does Java works? You would have created a file called .java here, right? Dog.java. You would have compiled this and then you would have ran that file, right? By doing Java and dog, right? So it would start executing. What happens when you start executing? Your JVM looks for the main method, right? So this is the first thing which will be getting added to your stack. Where does your main method goes? It's a method here, right? These are methods. Main, go, set name are method names. So I told you how once the execution starting, like JVM starts executing, it will first look for what method? It is looking for this kind of a variable, main, right? What this will do is this will first add this main here, right? It will add this main here in this stack, right? Now once it added the main, it now here, right, it sees that okay, I have to also accept argument of args, right? So args is again what? It's a local variable. As of now we are not providing any value to it, but this got added here, right? Let's say this got added here as an, okay, let me not write it here, let me write it here only, right? Args here, this is the args here. Now, so now the control of execution moves to this line, right? This line here, main, because this is now getting executed. So we are done with this line, right? So args was also found out, and args is placed here, right? This args is placed here. Now the this line here, right? Dog d is what? It's a local variable. Okay, d is a local variable. Where will you keep it? You will keep it here in this stack only, d, right? Now as part of this line, the next line you are doing d equals to new dog, right? As soon as you do this, right, new dog, right, an object of dog class gets created here. This is a dog, right? This is a dog here, right? A dog got getting created. When you do new dog, right, what is happening is it is creating a copy, right? It is creating a copy of your class, right? It's like your dog is a blueprint, right? This is completely a blueprint of a dog class. And whenever you do a new keyword, right, on the dog, it creates a copy, right? Remember we discussed this. You have class here, you have class here, right? Class is a blueprint, and as soon as you do a new thing, right, a new, let me name it as dog only, dog, right? This is the class. As soon as you do new dog, right, what happens is d equals to new dog, right? What happens is it creates a copy of this class, right? Whatever it has. What does this have right now? It has caller c and string name, right? At least on the instance variable side. So here what will happen is this d here, right, would be holding these values, caller c and string name, right? What is the default value which they will attain? We discussed about the default values of instance variables, right? So this is you're creating for the class, right? What will be the default value? Null. And similarly for the string, which is again a class, what is the default value? Null, right, everyone? So here what is happening is as soon as you do a new dog, it creates a copy like this. It creates a copy like this where c is pointing to null and name is pointing to null. So let us go back. So what I will do here is, if you see it, if you look at this, right, c here and name here are currently pointing to null. I'm not writing null. Okay, let me write null. Okay, null equals to null. Okay, name equals to null and c equals to null. So this is what is getting created when this line got executed. Okay, and what is happening is this d is pointing to this dog here, right? D equals to new dog, right, everyone? This is what happened. Now let's move ahead. Now here you did d dot go, d dot go. Now here this is the go method. Where does your go method goes? It goes again, it goes and sits in your stack like this here, right? And here what are you providing? You're providing a dog thing, right? This is the input which is accept, right? And you provided what? You provided d here, right? You see this? You're providing d here. So again, dog is a local variable. Dog here is a local variable, right? It's a local variable. So it also got added in the stack. But what is getting assigned to dog? What are you assigning to dog here? See this line. So when this line got executed, it invoked what? It invoked this method, right? Go method here. It invoked this method, and what value this dog received? This d here, right? So, and what does your d is holding? What is the value d is holding? D is holding this value here, right? So what will be the dog holding? Dog will also be pointing to this variable. Is it clear? This is the important part. Any doubt on this? Okay. So now both are pointing to the same object here, right? Both are pointing to the same object. Okay. Let's move ahead. Now since you invoke this, right, and dog received the value, let's move ahead. We now reach to this line. On this line, it says C equals to new caller. Where is C placed? What is this C? What is this C? This C is the this class, right? This dog class here. This is the thing which we had, right? This C here, this C here, right? And this C, which was created from this instance variable, right? And so this got created here, and C equals to new caller. Now, as soon as new caller is done, right? New caller here, it creates an object of caller class. Caller class. Now, caller class is empty. So I will not add any variables here, any instance variable here. So this is how it looks like. But who is pointing to caller here? Who is pointing to caller here? This C is pointing to the caller here. Okay. This C is pointing to this caller here. You can see this line here, right? This line here. This line here. Right? Now, what we are doing next? We are saying dog dot set name ICO. Now this dog, what is dog pointing to? Dog is pointing to this object, and this object we had these instance variables, but it also has these three methods: main, go, and set name. So it also has a method set name, right? Again, I will not add set name here, but okay, let me. How should I tell you here? Okay, okay, just a second. Set name. So you are doing dog dot set name. As soon as you do set name, will add set name here. So where do you add your local your method name? You add in your stack, right? I told you what does your stack holds? It holds local variables and method names, right? Methods which you add. So all of these two things are adding here only. So as soon as you invoke this, right? So a set name got added in the stack like this, right? What it does it require? It requires a string variable of dog name type. Now dog name is again what? It's a local variable. So it will be added here only. Dog name, right? And now what is happening here is what value did you provided here, right? At this line, what is happening? You when you invoke dog.setName, it tried to invoke this method, right? It will invoke this, and what value it will be providing to dog name? ICO. Now I told you when you're doing this, right? When you do this, so it is like you're doing string dog name equals to ICO. You're doing something like this, or you can understand you're doing something like this: new string ICO. Now this is the object creation. Where does your object get created? It gets created here, right? On the stack, on the heap, sorry. So here you will have a string object being created, and it will be holding what value? ICO. Okay. And who is pointing to ICO? Dog name. You can see dog name, right? It is receiving this ICO value. So your dog name is pointing to your this value. Okay. So your dog name is pointing to this value. Your this object is being pointed is being referred by this dog and D, and this caller object is being referred by the C variable. Now if you move ahead, right, you also had this name variable, and now this name variable, which was your instance variable, is placed here. It is pointing to what? It is pointing to this dog name. This is pointing to your dog name, right? And in a way it is also, so what it means is it is pointing to this variable here, right? So name is pointing to dog name, which is here, and dog name is pointing to this. So name is also pointing to this, right? Now, why we are understanding all this, right? Okay, why we are understanding all this? See, now, okay, we will now understand. So this is how the invocation is happening, and this is, you can see, right? All the objects which we have created three objects: dog here, caller here, and this string here, right? And all these objects are sitting in the heap, right? Now we have to understand two important things here. Like we have added some information in the memory, right? And those would be picking up some of the space in the memory. Those needs to be released. Those needs to be released so that your memory does not get filled, right? And it makes space for something new, right? It has to be there. Otherwise, if you keep adding some one thing or the other to the memory, it will get exhausted. How will it have the space for something, for doing something else? How does it work is, when you invoke this main method, so we started from here, right? See, when you invoke a method, right, from the main, you can see when you did this, it was okay. When you did this, it just created an object. But when you did this, right, the control from this line was moved to this line, right? And your main method has not completed. Okay, please remember what you did here is, at this line, right, d dot go, the control from this line was moved to this line, right? So when the control moved this from this to this here, right, the what it also means is that your main method is not completed, and in between the program has moved the control of my execution from here to here. So my main method is yet to complete. When it will complete now? It will only complete once this go method returns the control back to the main method, which is at this line. And when will the go method will provide the return back? When it itself gets completed. Okay, so so the control from here moved where? To this go method here, right? This part, right? Now, so it moved to this go method here. Now, as part of this go method, you created a new caller object which you created, and again within the go method you invoked another method which is set name. So from here, right, at this point of line, the control from the go method went to this method, right, the set name, and now it will do whatever it has to do. So again, the go method is not completed. So your go method is also uncompleted. Your main method is also uncompleted, right? But this is the one which was invoked first, which is placed here. You can see here, right? And then it was the one, the go method was invoked second, right? And within the go method, the control has moved to set name, which is here, right? Now, when will the method provide the control back, so that this method, the method which from which this is called, gets completed? So here, right, I think it's set name here, right? You can see it has just one line which says name equals to dog name. So it did this, right? So name is pointing to dog name here, right? This name is pointing to this dog name. And as soon as this line is done, right, and this control is done, what will happen? Try to understand what will happen. Your method here, right, is getting over. As when I say it is getting over, right, it will be moved from here. So it will be removed from stack. And as soon as you're moving a method from the stack, right, the local variables which you would have created here, right, are also getting removed. Okay, are also getting removed. Where is your local variable sitting? You had one local variable created here, which is dog name, which was this. Now your dog name will also get removed. Okay, so this will get removed, this will get removed, and this dog name was pointing to this. So this reference is no more anymore, right? So this reference will not exist anymore. So now your dog name will not point to this. So this is gone, right? So this reference does not exist. Okay, but as part of the exercise within the set name, you made sure that someone is accessing the dog name. I mean the value, this ICO here, right? Now who is pointing to ICO? Name variable, which was your instance variable. So from here, the someone is still accessing ICO here. Okay, is it making sense? We are trying to learn here what is the flow of our execution. Okay, so now our set name method is done. We are good with this. And as part of it, once our method got completed, all our local variables are also gone. So dog name is gone, set name method is gone. Now the control, since this got completed, where will the control be moved back? It will be moved back from where it came. It came from here, right? Set name. So now once this got ended, right? Once this got completed, and now what is there pending in the go method to run? Nothing, right? It will just complete this method also. So the same behavior will happen for the go method. Now the go method is about to complete. So what are the local variables which were created as part of it? I can see only one, which is dog, right? The local variable. So this will also get removed. And now this dog will not point to this here, right? It is not pointing to this object here anymore. So this reference is also gone. Okay. So this reference is also gone because dog variable does not exist, which was pointing to this variable here. And now the go method is completed, right? There is nothing else here. So this dog method is also gone. So now what does your stack have as of now? Your stack only have these three things: D, args, and main, right? Now, so as soon as this got completed, this is done. Now the control moved back to the point from where it came. So it came from here. Now, as soon as this line got completed, your main method is also about to get over. Now, what are the local variables? Args and D. Now see, D is also pointing to this dog here, right? So this is also gone. Now, one of the important thing, your dog object right here is not being referenced from any of the variables, right? So what does it mean is whatever variables which were pointing to this, right, does not exist anymore. So it is like this object here, which you created in the heap, right, is unclaimed. No one is claiming this object now. Okay, no one is claiming this object now. So this is just floating like in an empty space. Okay, you can understand this. So now no one is pointing to this dog object. Why I'm telling you this, I will tell you that. Okay, I'll come to that part. But you can understand no one is pointing to dog. There were only two things which were pointing to it, and both were local variables, and both are gone now. Okay, so we are good with this. So this D is gone, right? So this D will go away. And now args was anyhow not accepting any inputs, right? So args was not pointing to anything. So the args is also gone. And after this, right, you have to understand your once this gets executed, the control moves to this line, and as soon as it goes to this line, your main method is also done. Right? Your main method is also done. So main method will be removed from the stack. So your stack is empty now. There is nothing in the stack. There is nothing in the stack now, right? But what do you have currently? You do have some objects sitting in the heap, right? But let's try to understand, does these objects which are existing here, are they accessible from the outside world, or they are just accessible inside the heap? See here, right? And you can understand, right? As soon as your main method gets executed and whatever it has to do is done, right? What will happen? JVM will stop your execution. So for JVM, your program is done. It does not have to do anything with it, right? So it is done with your program. So the execution will stop now. Now, when the execution is stopping, you have to understand that your stack got empty as part of the execution process, but your heap still had some of the objects sitting there, right, which are unclaimed. Because when I say unclaimed, you have to understand that no one from the stack is accessing them, right? No one is accessing them. So these are all ideal objects sitting there, right, doing nothing. What will happen to them? Because if we leave them as is, they will consume some space in the memory, right, which you don't need, right, which you don't want. So what happens to these? Here the role of garbage collector comes in. Okay, garbage collector in Java is a process, right, which makes sure that it is cleaning up the objects, right, or the things which are not accessible anymore. It keeps removing them. Okay, so garbage collector in Java, right, garbage collector in Java will make sure that it will see whether whatever objects you have currently, are they accessible from somewhere, from the outside the heap. You can see, right, dog was being accessed from this dog and this D, right? Now both are gone. So no one is accessing this dog object now. So this is a good candidate to be removed by garbage collector. So garbage collector will definitely remove this, okay, from the heap. So your heap is getting empty so that it can have some space. So your dog object will be removed. Now it will see who is accessing this ICO. Okay. So earlier the dog name variable was accessing this, but now it is not there, right? But I can see that there is a name instance variable which existed, which was accessing it. But this is also sitting in the heap, right? So now once garbage collector will see this, it will then see who is accessing name. No one is accessing name because the program has already ended. So what will happen is garbage collector, what the garbage collector will do? It will remove this also, and it will remove this also. And now comes the last part. It will see the caller also. Again, caller, no one outside the stack was accessing this, right? And here, right, C is the variable, instance variable, which was accessing it. Now C is accessible by no one, right? Because the program has ended. So C is gone, and as soon as C is gone, your caller object is not accessible from anyone. So this is also gone. So now your heap is empty, your stack is empty, and this is how the execution happens. Okay. So now if tomorrow someone asks you about like how memory management is happening in the Java world, right? You have the answer. You can show them that okay, this is the rules of it and this is how it works. Okay. And why we discuss all this, right? See, this is very important. This is very important because you have to understand what is happening where, right? In the stack and heap. Okay. The concepts of pass by value and pass by reference, right? It is very confusing for all of us, right? Even for me. Okay. It gets confused here. But every language you study, C, C++, Java, or maybe something else, right? You would keep hearing those words, okay? That there is a pass by value, pass by reference. Now, what do we really mean by that? Okay. First of all, my objective of teaching you this stack and heap part is that you understand that what thing is placed where. First objective. Second objective is to understand how your program execution flow really happens. Okay, we understood like how it really happens and how these things are added to stack and how they are popped up from the stack. Okay, and what really happens to the objects which are getting created in heap, right? Which is being taken care by the garbage collector, for which you do not have a control on. Garbage collector is something which is configured to work in autonomous mode. Okay, so it works by its own, by the logic which the Java developers would have created, right? But how it works is it tries to see that the object which that garbage collector will try to collect and remove it from here, it should not be accessible from the outside world. If it is accessible somehow, it will not remove it. But you can see, right, in our program, everything which we created inside the heap was not accessible anymore. So it removed everything one by one. And this is how your heap memory is kept empty, right, or stable, right, without adding something extra which you do not want. Okay. Okay. And the another last objective of you telling all this is that you understand that when you are doing some new keyword, right, when you use new thing, right, you have to understand with every new thing you do, right, a new object gets created here. Okay. One last thing. Okay, one last thing on this discussion. I hope everyone has worked with Selenium. Okay, I hope everyone has worked on Selenium. Have you tried to open a browser in Selenium, everyone?
No,
Sally?
I've never done anything in Selenium. I've not even seen it.
Okay, you have not done it. Okay, okay, no worries. See, the first line, right, which you would be writing in Selenium to work with the browser, it would look like this. You will be doing WebDriver. Okay, let's not do WebDriver since we have not discussed the interface. Let's use Chrome driver directly. Chrome driver wd equals to new Chrome driver. Okay, you would be using a line like this. Okay, what this line does is it opens a browser for you, right? And what is this Chrome driver? It's a class provided from your Selenium package. Okay, Sally? And that class over there helps you to open a browser so that you can automate something on it. This understanding should be enough for you as of now. Okay,
Okay.
right? So what happens with this is it opens up a browser. Okay, so it opens up a Chrome browser for you where you could automate things, right? Like filling up the data, accessing a URL, uh, clicking on a button and all that. You can do it afterwards, right, by using this wd variable. But we have to understand what is happening with this line. Whenever you use a new keyword, what happens is it's an object, right, which is getting created. Where it will create? It will create in the heap memory. So a Chrome driver object gets created here as soon as a new keyword is shown, right? So our object is created. And now you have to understand this object is the reason that it will open up a new browser, right, for you. Okay, and you will be working on it. If you do not, if let's say that somehow you again created a new instance, new Chrome driver, right? And you again assign this to variable wd again, right? The one which you created above. You have to understand what is happening with this line. This line is doing something like this, right? Let's say you have a workflow where you wanted to log in, on the screen by the username and password, and you will submit, right? You will do this username and password and click on submit. This is the login screen. And after the login screen, you will see a home screen. Okay, a home screen where you would need to click on a link here. Let's say there's a link on which you need to click. So this is the flow. You open up the website, you fill the username, password, you click on submit, and then you move to the home page, and then you click on the link, right? Let's say that you wrote a code like this. You wrote like this: Chrome driver wd equals to new Chrome driver. Then you did dd wd dot get. You provided the URL here, and then you did wd dot find element, and you did whatever you want to do, and then send keys, right? And then let's say you did wd dot find element again with something, and then you did you clicked on the button, right? Click, and as soon as you clicked on the submit button, it moved to your home page, right? Somehow, let's say what is happening here, right? Let's understand this line. What this will do is, as you can see, a new keyword being drawn, so it will create a new object here, and it with this object will create a new browser for you, right? So this is your browser one of Chrome, right, which got created. Now you are doing, when you're doing all this, right, you are doing on this browser. Okay, you're doing on this browser because this browser is pointed by this object here, right? But let's say that in your process you did something like this again. You did new Chrome driver, right? Somehow you did this, and you're trying to do now. You're trying to click on this link, wd dot find element dot click, right? What will happen here, right? I'll tell you what will happen here with this line, right? This is happening, right? But what this line, what will happen is it will create a new object for you because it saw a new keyword here, right? Create a new object. As soon as it creates a new object, it will open a new browser for you. Okay, it opens a new browser for you. This is the browser 2 of Chrome. You did the login part here in this browser, and here you are expecting that you will be able to click on this link, which only comes after login. But as soon as you open a new session, what will you see? Are you, I mean, will you get logged in by yourself? No, right? What will you see here? You will see the login page again, right? Not that home page. Okay, so you have to understand that whenever you do a new keyword, right, it creates a new object for you in the heap, right? And it's like a new thing altogether. So you have to be very mindful, right? Whenever you're trying to create a new object, you need to understand like what are you really doing. And in the case of automation, web automation, right, this is one of the biggest reason where people fails to achieve parallel execution, where people fails to do the correct I mean, because of which the flakiness gets introduced in the framework, right? Apart from the not writing a good export, okay, or that locator strategy. So you have to understand whenever you do a new keyword here, right, it creates a new object, right? And it has a meaning, right? And it will like a new thing which gets created here, which will be used. Okay, I think it will make more sense when we talk about Selenium, but you have to understand with this new keyword, you create a new object altogether, okay, which is doing something else, and there is no relation between these two as of now, right? These are no these are very isolated objects being created there, okay, which will be doing their own part. They do not, this does not know about this, and this does not know about this, right? So ideally what we should do is we should create only one object and start working on it so that the continuity of our execution can be maintained on the same browser, so that there is no session interruptions there. Okay, okay, coming back to our part here, right? I hope that this program, the execution flow of the program is clear to everyone, how the what values will be stored in the stack and what values will be stored in the heap, right? And how do they get cleared out. Okay, for stack it happens automatically as the program runs and completes, and for the heap, garbage collector takes care of that part. Okay, any question on this part? Okay, great.
Clear,
Yeah, sure, please.
clear. It's
Oh,
clear.
it's clear. Okay, okay, clear. Great. Okay. Okay. So if it is clear, let's move to the next topic. Okay. What did I tell you? What I'll cover? Our next part is we covered about pass by reference and pass by value, right? Let's cover this part. This is again a very important part. Okay. And to understand this, we had to understand this part, right? So that's why we learned that thing, right? Let's do it. Should I do here only? Yeah, let's do it here. Okay, what do you mean by pass by reference and pass by value? Does anyone know? Is Java a pass by reference language or a pass by value reference? I mean, what does Java support? Does anyone has an answer?
I think both the kill
Hmm.
pass by value and pass by reference. It will pass the copy of the value and the copy of the reference. If you make a change to the pass by reference, it will affect the original value. Whereas in the case of pass by value, it will not affect. It remains constant. It remains same.
You're absolutely correct, but tell me one thing: what would be considered as pass by reference, and what would be considered as pass by value in Java?
Variables are considered as pass by value. I
When
mean,
you
primitive data types.
okay,
Whereas objects are considered as pass by reference.
great.
That
You're
includes arrays. Yeah.
absolutely right. This is how it works, right? So first of all, everyone, right? When someone asks you this question, right, whether Java supports pass by reference or pass by value, you have to answer it supports both the things. Okay, how does it support both the things? We are about to learn. But the second question can come to you is people can ask, okay, if you are saying Java supports both, tell me which area of your program is supported as pass by value reference and which area of the program is supported as pass by value. Okay. Now, what do we mean by reference? Reference, you can understand that when you are okay. Uh, what should I say? How should I tell you? See, reference means, let's say, okay, uh, okay, let's say that I have a locker. Okay, I have a locker. This is my bank locker. Okay, this is my bank locker, and I have placed one document inside this locker. Okay, so there is one document which is sitting inside this locker here. Okay, now there are a lot of people who wants access to this value. I mean, who wants access to this document, let's say, right? Now, uh, if I talk about pass by value, right? Now everyone needs this thing right here. Let's talk about pass by value. What will happen in this case? Pass by value. If I use this concept, right, just literal meaning of it, what does it mean? What does pass by value will mean is that you are you can understand that you are that to these guys, right? See, they are asking for this document, right? And as a banker, you understand that you have to do this transaction by pass by value. So what you will do in this case is you will try to save your original value with yourself, right? So that no one can make change to your original value. Okay. What will happen in this case is you will just try to create a copy of this document and hand it over to everyone here. They're all individual copies like this. Okay. So this is what mean by pass by value. So now if they make a change here, right? If they make a change in their copies, right? Nothing is happening to your original value. Okay. So understand this way, when you someone says about pass by value, right? What it means is you are not handing over your original thing to the other person. Rather, you're keeping your original thing with you, but you're creating a copy of it and passing it to someone else. That please use it. And if they even change something in it, it is happening in their own copy. Nothing is getting impacted at my side. Okay. What is pass by reference? In case of pass by reference, I will have to give this copy to the person who is asking it. So in this case, right, what I will do is, you can understand in this case, I would be giving this exact copy to them like this, right? And whatever change they do, right, the same change will be happening here, right? Because it's that copy itself, right, which I'm handing over to them. Okay. So pass by reference means you are giving the original copy, right? But pass by value means you're creating a copy and passing it to someone else, so that if even if they make some change, you are not impacted. Okay, I hope this is a very simple right, explanation of it, and this will help you to remember this part. Okay. Now, what is pass by reference and pass by value in case of Java? Let's do this last part for this. We understood about the stack and heap, right? Let's say I am writing this thing here. Let me think. Tuck, 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 new. Uh, mhm, okay. I have to create the copy of it. Okay, let me first create this stack. This is stack. This is my heap. This is my heap. This is my stack. Okay, and I will create an address table here. Okay, an address table here for this and for this heap. Okay, for this heap. What I will do is at the level of the stack, right? I will have three columns. One is the identifier. The second is the address of it, and third is the value which this identifier has. Similarly, for the heap, I will have the address here and the value of it. I don't have an identifier because all the identifiers, the local identifiers, will be placed in the stack. Okay. Okay. So let's say I write something like this. So there is a method public static void main, public static void main. Okay. And here I created string array of args type, and I open these brackets here. And here what I'll do is I will write here, let's say, what should I do? Let's talk about string only. Let's say I'll create a string variable, string name equals to new string, right? And I will provide the value as Akhil. Okay. Now let's understand this thing, right? You're forget about main and everything, right? I'm not talking about the methods and on everything here. We are just talking about the variables which we are creating here, right? Not the methods. So here, right? When you talk about this name here, right? This name part, this your name is what? Is it's a local variable because it is being created inside the method here. So where will you be adding here? In the stack only, right, everyone? I have created this string name variable inside the main method, right? So this name would be getting created in the stack. So how does Java store this, right? I show you pictorially like how things happen, but it's not like this is how this happens, right? Java, or for the memory management, Java would be creating a table or for its own reference where it knows like what is my identifier. My identifier name is name, right? What is the address, the memory address which it will take inside of stack? Let's say it took the address space as 0001. Okay, right? Now what it is pointing to? It is pointing to this Akhil thing, right? Which is a object which will be of string type. Where does that get created? It does not get created here. It gets created here in the heap thing, right? Like here. So you will have a string object being created which has a value Akhil, right? So similar to stack, right? When you added a value here, the entry is maintained. Similarly for the heap, when something is added, an entry would be maintained. The entry would be the address position of this Akhil thing. Let's say the address position is 0002. Okay, let's say in the memory. And what is the value here? Akhil. Now what is happening here? Your name variable which was placed here has to point out to this object which is sitting in heap, right? Your name, which is a local variable, has to point out to this thing, right? This is how it has to look like, right? Right? Your name is pointing to this object here. Now, in the table, if I see in this stack, right, I showed you there is an identifier called, let's say, which is pointing to the variable name, which is name, the address of it. Let's say this see, stack is a memory, right? There would be some memory address, right? Which where this name variable will be stored. What is this? Where this name address is being stored? It is stored at this position. But what value it stores, right? What value it points to? It is pointing to a value, to an object which is placed in heap. So for that, an entry exists in the heap, right? So what will be the value placed here? Will it be Akhil? No, it will not be Akhil. It would be rather 0002. So it is pointing to the this value here, right? Which is here. Now, once you know this address, then you know that what would be the value placed at this address, which is this. So in a way, when this name thing, right, is trying to access, is trying to read this, right, what it is doing, it is like, first of all, this is the address position of the stack. So this is name is placed at the 0001 address, right? And this so name is placed at this address position. So this is address number, right? So name is the variable name, which is the identifier, and the address position is 0001, which is placed here. But what is the value which name has? It does not have a value which sits in stack. But what is the value does it stores? It stores, it is pointing to an object here. But where does your object get stored? It gets stored in the heap. In the heap, the entry is like this, address and value, right? So let's say the address position of this Akhil object is 002. So an entry is made, and what is the value stored at this position? Akhil. So it is placed here. Now, this name will not directly point to Akhil, rather it points to this address position, right? This address position. Now, in this case, right, when you are not directly accessing the value, but rather you are accessing the address of that variable, right, of that thing, right? This is called as pass by reference. Okay, this is called as pass by reference. So now what you have to understand is, if you have a local variable which you created and it is pointing to your object, right, on the memory, on the heap. So this operation is happening through pass by reference. Okay, because local is placed in under your stack and your object is placed on the heap, right? And here, if something tomorrow happens to the original value, if I go back to our original this part here, right? Where did I create that local? Right? So what is happening is, tomorrow if I make a change in the my original value by myself, let's say, right? So what will happen? If I provide the by reference, right, everyone will get that copy, right, of it, where they will see that change. Okay. Okay, right? But you have to understand like why this is called pass by reference, because here you're not giving the access to the value directly, but rather you are giving the access to the address, right, from which it will auto calculate what is the value being stored. Okay, which is Akhil. So in this case, this will happen. But if let's say that I have two variables, int a equals to 5, and I do something like this, int c equals to a. Now what will happen in this case? Now both of them are local variables, right? Both of them are local variables. So where they will be stored? They will be stored. So this is 9, right? 9. Sorry, a. Sorry, a. Right, a. So first of all, this int a is a local variable. It will be stored here. Let's say it is stored at position address position 003. 0003. So a is placed here, right? Now what is the value which is a is holding? It is holding 5. 5 is not an object, right? It's a primitive data type. So where it will be pointing, it will be placing the value here itself. So a is equals to 5 here itself, right? So it is pointing a equals to 5 in this stack itself. So now what does a points to? A does not point to an object anymore, right? I mean, it is not pointing to any object. It is directly pointing to the value which it needs to hold. It needs to have this 5. Okay, which is 5 here. So nothing linked to the value which may be sitting in the heap, right? So a has the address position and its value is still accessible from the stack only, right? So stack knows what value it has. It is not the address. It is the exact value. Okay. Now int c equals to a. If I do this now, what this will do? This will create a variable local c in the stack again, it will give an address, the address position of it. Let's say 00004. Now what will happen is C is assigned here, okay, and the address position is given 004. It is saying that it has to access A, right? But in this case, right, what will happen is it because this A is sitting in the stack itself. So stack here knows that, okay, that A, I know a value of A, right? I know the value of A. What is the value of A? 5. So it is not that it will place A here, rather it will place the value of 5 here. Okay. And this, in this operation, right, since in this case, right, stack knew about the value, right, it just plays the exact value here, right, which is pass by value. Okay, so this operation here, it is pass by value. Okay, everyone is getting their own copy, right, of their own copy. So if they, whatever they want to do, they can make a change in it. Now if now, right, let's say after this I do something like this, A plus plus and C plus plus, what do you think will be happening? What should this will print, and what should this print? Let's see this. Let's see this actually. Let's close all this. It would be interesting. uh, Pass, let's say. Okay, and here let me add a method main, and I am doing something like this: int A equals to 5, int C equals to A, right? And after this I am doing A plus plus, and I do C plus plus. First of all, you guys tell me what should be the output here for A first of all, and S out for C. So if this operation goes by, right, if I understand this, what I am saying is, okay, I'm not saying anything. You tell me what should be the output being printed at line number 10. I am giving you some options. Tell me, should it be 6 or should it be 7? Similarly for C, should it be 6 or should it be 7? There is no B. We have A and C only. Abhilash is saying 6 and 7. 6 and 7. Let me rethink. Will it be 6 and 7? Okay. Okay. Let's see. Okay. How many of you think it should be 6 and 6? I think Ashok mentioned it.
Yeah, 6 and 6.
Okay. Someone else thinks it should be 6. Kusuma also thinks it should be 6 and 6.
Yeah.
Okay. Fizula, what do you think? Fizula not there.
No, no, which is away 1 minute. So this 5 will be 6 and wait, just think for a minute. 1 minute.
Mhm.
Yeah, 6 and 6, right?
6 and 6. Okay. Shouldn't it be this way, Fizula? Let's say, okay, let's first run this. Okay, let's first remove the confusion. Even I got confused whether it should be 6 or 7. Let's try to run this. Hopefully I am correct. Let's see. If I run this now, what I expect is it should be keep doing, man, 6 and 6.